Hi Algebra 2 girls, this is the video for Friday, November 30th. And this video is going to cover section 3.7 in your textbook. In section 3.7, we already covered topics involving determinant, so a specific quantity that you can find from a matrix, either a 2x2 or a 3x3, or any square matrix. Today, what we're going to do is see how we can use determinants to solve systems of equations. So there are multiple ways to solve systems of equations with matrices, but the ones that we're going to talk about today involve a principle known as Kramer's rule. So if you look in your notes packet, the first problem that you come across asks you to solve the systems of equations using either substitution or elimination. So you've got a decision about which principle you would want to use, but anytime we see coefficients in front of every single x and y variable, it's usually going to be a good idea to go with elimination instead of substitution, just because it's going to be tricky to get a number by itself. So looking at my coefficients here, I have a 3 and 2 in front of my x's and a -4 and +5 in front of my y's. So I'm going to go ahead and eliminate the x's just because the multiplication process is going to look a little bit easier. So let's go ahead and multiply each term in this equation by 2, and then we'll multiply each term in this equation by 3. So when we do this, we're going to find that we'll be able to get those x's to go away. In our first term, this will become 6x minus 8y is equal to -30. Then in the bottom, when we multiply that by 3, we get 6x plus 15y is equal to 13 times 3 is going to give me 39. Now remember, when using elimination, you have to decide which sign to use to get rid of your variable. Since my 6's are both positive, I'm going to subtract to make things go away. So those disappear. Then I have -8y minus 15 more. So I'm subtracting, and I'm going to end up with -23y here. Then on the positive side, after I've done that subtraction over on the left-hand side, then I have to work with the right-hand side. And so I end up with -30 minus 39 more, and that gives me -69 over here. So then I can divide both sides by -23. And when I do that, my y value is going to be equal to +3. So that's my y term. Then I need to go ahead and solve for my x term. So I'm going to pick to solve for x using this equation here, just because it's the one with the smallest possible coefficients. So here I'll have 2x plus, I'm using 5y equals 13. So in place of y, I can substitute in that 3 that I found. So I've got 5 times 3 here. That's equal to 13. So this becomes 2x plus 15 is equal to 13. I can subtract over that 15, and so I will have 2x is equal to -2. I can divide both sides by 2, and so my x value is going to be -1. So my final answer solution here is going to be the ordered pair, -1 for x, +3 for y. And that's my final answer, so I'm all done with that one. And again, anytime we come across a two-variable system, we've got options for whether we want to solve with substitution or elimination. It's really up to you with regards to the coefficients. So those are algebraic methods. We actually can find out that same information using matrix methods. And that's what we're going to take a look at here with Kramer's rule. So Kramer's rule gives you a technique where you're just taking numbers from the system and setting up matrices. Once you set up the matrix, you're using the determinant of that matrix to then solve for your x and y values. So let's go ahead and do the same problem that we just did algebraically, but this time we're going to solve it using matrices. So anytime you want to solve a system of equations using matrices, the first thing that you need to identify is a matrix known as the coefficient matrix. So the coefficient matrix just takes each value in front of the variable on the left-hand side of your equations when they're in standard form and puts it into a matrix. So what I'm looking for are my A, my B, my C, and my D terms in a system of equations. In this case, that's going to be 3, -4, 2, and 5. So I'm just going to take those numbers and put them in a matrix here. So I've got 3, -4, 2, and 5. And we usually call that matrix A. Sometimes you'll see it written as matrix D. It just depends on the textbook or the source that you're using. Then you want to go ahead and find the determinant of that matrix. So determinant A. Remember that if you want to find the determinant of the matrix, you just multiply along your diagonals. So A times D. In this case, that gives you 15. And then you subtract multiplication along the other diagonal. In this case, 2 times -4, that gives you -8. So here I'll have 15 minus -8. That's the same thing as plus 8. So this is going to give me 23 as that determinant. So you want to hang on to this matrix determinant, and we're going to set up and solve for 2 more matrix determinants. The 2 more matrix determinants that we set up and then identify are going to give us our values for x and for y. So what we have here over on the right in this blue box is the equation that we'll use for Kramer's rule every single time. So if you notice for x, it tells us to set up a matrix that goes E, B, F, and D. So when it comes to E, B, F, and D, those are going to be just different values that we're looking for in our equation. So E is going to be the constant value that you have out on the right-hand side of your first equation. B is the coefficient here. F is the constant value on the right-hand side of your second equation. And then your D value is just this term right here, this positive 5. So let's go ahead and set up that matrix for our X term that we'll use. So we put our E term, -15 right here. Our B is -4. Our F is 13. And our D is positive 5. So all I'm doing there, you guys, is matching which numbers in this systems of equations match the coefficient values that are given for me in the Kramer's rule definition here on the right. Then I'm just going to take the determinant of that matrix. I'm going to call this determinant of x. So when I do that, I multiply along this diagonal here. -15 times 5 is -75. And then I subtract along this diagonal. I'm going to have 13 times -4. So when I perform that operation, I end up with -52 here. So all that I'm going to do in this case is to subtract here. So I've got -75, but subtracting a negative means that I end up adding. So I get -75 plus 52, which is -23. So in order to solve for x, all that I have to do is divide that determinant by my original determinant that I found. So x is going to be equal to -23 over 23. So my x value is going to be -1. Then I'm going to set up and solve one more matrix determinant in order to get my y value. So now I'm going to set up a matrix determinant that has A, E, C, and F. So here, my A is this term out in front. E is still my -15. C is this term out in front. F is that term over on the right. So the matrix that I want to set up to solve for y involves 3, -15, 2, and 13. And I'm going to find that determinant. So the determinant of this value, I multiply along my diagonal, A times D. 3 times 13 is going to give me 39. And then I'll subtract 2 times -15. So 2 times -15. That's going to give me 39 plus 30 because the two negatives will cancel each other out. And I'll end up with 69. So then my y value, I'm just going to take this determinant here of 69 and divide that by 23. So my y value that I end up with, oops, not 1, that's going to be 3. So my final answer for my ordered pair is going to be -1, +3, which is the same value that I found using substitution or elimination when I was solving this system algebraically. So we're going to go ahead and try 2 more systems of equations using Kramer's rule, and we're going to follow the same process each time, where we go through and set up 2 different matrices, take their determinants, and then we divide those numbers by the determinant of the coefficient matrix.